I use a ton of UPS units like this. These cheap consumer ones with the USB port, and even better ones that have the charger ports right here. And I will put these on not only every computer that I have, but also things like lab equipment, televisions, stuff like that. The only problem is I don't have a way to monitor these. Now, connecting it to a computer, I can just plug this USB. I can just use a USB cable to plug in here and plug into a computer, and then it'll tell me, whenever the battery is drained and gracefully shut down the computer and that sort of thing. But I really want a way to monitor this on the network. So the easy way to do that is to just buy one of these more expensive units that already have a network management card put in it. But I have a better idea for this, and that is to use one of these to connect to the UPS and then connect it to Wi-Fi so that we can then monitor what's going on with the UPS and maybe even send some commands to it. So the first thing we're going to need is Raspberry Pi, and you can use any variant of this, but I like this one because of the size. And I used to be able to get these things kind of bare bones that would come in like, a little anti-static thing, and it just have the circuit in it. I had to buy this kit. So let's see what's in that. Okay, so we have, I used to get them raw like this without having to mess with a kit, but this works just the same. So whenever you get these, you want to make sure to get one that does not already have the pins soldered on here. I mean, this comes with them. In case you wanted to add that, we're not going to use it. They'll get in the way for the case that I like to use. Let's see, what else do we got here? We have our, this is a mini HDMI to HDMI adapter. You might need this if you want to do troubleshooting, that sort of thing. But once I put these into production, we're not going to need this. And then, what is this? Oh, got a little heat sink. I don't know if that's necessary or not. And then our little... Now, I haven't seen ones like this. I've seen them where they're micro USB here, but then has like 3 or 4 of these ports, because I'm obviously we'll need more than one. But I guess this is fine if you want to plug in like a dongle for wireless keyboard, mouse, or something like that. Again, I don't think we're going to need that. So at the bare minimum, we need Raspberry Pi. This is the case, and I'll put links to this all in the description, but this is the case that I like to use for it. It's nice and compact, and I can just use some double-sided tape to stick it on the side of the UPS. So we're going to need that. We're going to need a micro USB to USB-A for power. And conveniently, a lot of the modern UPSs have a charger port on it, so this can plug straight into that. So this has 2 micro USB ports on it. This one closest to the edge here is just for power. This really isn't a USB port, at least not that I've seen. And the middle one in here is the actual USB port that will connect to the UPS unit. And in order to do that, I picked up some of these, and this is a weird cable that I haven't seen before, but it's micro USB on one end and USB-B on the other end. So this will plug into the square USB slot on the UPS. You may recognize, the end of this is something you'd plug into a printer or whatever, but this is the first time I've seen them with micro USB on this end, which is awesome because it can just plug right into the Raspberry Pi and plug into the UPS, plug that one into power, and then you've got something fully self-contained here. We'll also need a micro SD card and a micro USB reader or micro SD reader you can plug into your computer. Computer may already have one. You may already have one. I had to get one for this. And then, like I said, if you want to connect a video, mouse, and keyboard to this, you will need this. I guess this is mini HDMI to HDMI adapter, along with, you know, something to plug in there, and you can plug your keyboard dongle or whatever. When we actually write the operating system to the SD card, we will set up the wireless network and all of that stuff to get it to where we can manage it over the network and don't have to plug a display or anything into this. Okay, so the first thing we're going to need to do is download the Raspberry Pi imager. And then we'll need to plug in our SD card USB reader thing. And go ahead and run it. So now we need to choose device, and we're using the 02W, which is this one. And then OS, I like to go with the light version of this because, I mean, all we're using this for is to monitor UPS. It's not like a desktop environment or anything. So we'll use this Raspberry Pi OS Lite 64-bit. And then, of course, choose our storage. And then here is where we can put in our Wi-Fi settings and what password we want to use and all of that. That way, whenever it connects to power, it immediately connects to the Wi-Fi network, and then we can manage it with SSH and whatnot without even having to have a screen and keyboard and mouse in front of it. So we can go ahead and set up our host name. You can use whatever you want here. I'm just going to do UPS monitor just to make it easy. Set username and password. Let's just do user and then very secure password. And then here's where we put in our LAN information, which I'm having to look for it here. Vector Sigma -2G. Then wireless LAN country we have to select because it controls the radio on this. And is there no easy way to scroll down? Okay, well this sucks. Can I just go to it? There we go. Okay, set locale settings. America, Chicago. I don't know what this is. US, maybe. All right, we have everything we need there. Okay, after all of that is set, we can go ahead and hit save. Well, let's click over here to, yeah, this is an important step here. Enable SSH. And then we can go over to, yeah, sure. I'll take this telemetry stuff off. So now that we have everything set up the way we want it, we can go ahead and hit save. And then would you like to apply these OS customization settings that we just saved? Yes. Yes. And then this will write the SD card. Okay. Okay, we've got that written. We can set that aside. We can drop a bunch of stuff over there. Actually. Okay, now we can start putting this together. And then this, where it has the holes, so you need to be lined up. And then it has these little cutouts here where the edge of the circuit board goes in. And then it just sits in there like that. And then this just kind of snaps together. And then we put our little SD card in here. You should be good to go on this. Now, normally I would just connect this to power and then look for it on the Wi-Fi network. But I think I'm going to try and hook this up to video and keyboard and mouse and then capture that so we can see what it looks like booting up. So I lost my microphone on that one, but we did see that it booted up. However, the very last line of that, if I can switch back to it here. Whenever I switched over this before, we did not see an IP address there. So now we do. So now let's see if we can actually SSH into this. Looks like 192.168.135.125, and it looks like it's still doing stuff here. Let's see, did I ever install PuTTY on this thing? Probably not. Oh yeah, I did. Okay. Nope, no I didn't. It's trying to... No, don't do that. Go away, Microsoft Edge. Alright, we need to download PuTTY. Okay. Now, what was that? 192.168.135, 126. Or maybe not. $135, $125. I can't read. Okay, here we go. We will accept this. And here is where we will put in our username and password that we set up with the customization settings. And here we are. We can get to this. We did not have to press any button on the keyboard or even look at the video because we were able to set all that up with Raspberry Pi Imager. So let's make this a bit more readable. Okay, so now that we're logged into the RPi via SSH, there's a few things I like to do on all of these systems. One of them is to set up the unattended upgrades, which is basically automatic updates. So there's a few commands to do that. I'll put these in the description, or probably more likely on the GitHub page. So what this does, it updates the sources for APT and then does any upgrades that are pending. And this will probably do nothing. Make a liar out of me. Okay, since we had to regenerate the init RAM FS, let's go ahead and reboot before we do anything else. Okay. We'll do that again just to make sure we got everything. I'm too used to Windows updates where you got to run it 3 or 4 times to get them all. And then this will install the unattended upgrades package. And then these 2 commands will turn it on. Screwed that up. Let's try them one at a time here. Okay, now that that's done, let's get our software on here that is going to talk to the UPS and then allow clients over the network to interface with it. It's called NUT, or Network UPS Tools. And now we need to edit the configs to tell it what it's going to be connected to, which most of the time these will all be the same. So the main config file, we just need to change this mode to net server. And then this is where we define our UPS units. So we're going to do very, very generic here and say my UPS. The driver on all of these is almost always going to be USB HID -UPS. That's the human interface device layer on USB that allows it to talk to the UPS via the USB port. This is a lot of acronyms on here, but this is what we need to make it work. And then port is automatic. I will say on some of this stuff, if it's just one UPS, which is what we're doing, this is fine. If we start getting into where we have multiple UPSs, we have to define something else in here in order for NUT to be able to tell them apart. And typically that's serial numbers. And there are some manufacturers out there that don't expose any kind of serial number or really anything unique from one to the other. So if you have a couple of those connected up to it, you're kind of SOL. So that's all we need to edit on this file. So we can save this. Now we need to edit the upsd.conf. Tell it to listen on whatever IP address it has. And then we'll save that. And this is where we define our users. Again, we're going to be ultra secure here. Please change this to something that is not admin like I'm going to do here. And these actions set in inst commands, all this is what allows somebody on the network to control the UPS. So if you leave this out in the open and somebody gets on your network, guesses admin, and then wants to play around with your system, they can turn off your UPS and run the battery down, turn off your equipment that's plugged into it, or rather basically just turn off the power to it. So you want to keep that in mind and make that a secure password. Okay. And then now we need to connect the actual UPS here. Okay. Let's get this out of the way. We're not going to use that, so I'll go ahead and unplug that. Then here's our UPS. And there's our pie that I almost squished. Then we got a little USB A/B cable here just for now. We'll plug that in. Oh wait, no, this is the right. This is the USB-B to micro USB. And then we'll... Man, that's in there tough. Go ahead and plug that in there and see if anything came up on the console here. Nope. Unplug and replug. I figured something would be echoed to the console, but yeah, maybe not. Let's look on PuTTY here. Yeah, there we go. Okay, all right. So it sees the UPS. So now let's do nuts. Oh, come on. Net server restart. Okay. Now we can do UPS-C, which is like the nut client. And now we have our my UPS here. Okay. So we can do UPS-C, my UPS at localhost. And then this is all the information that NUT is monitoring from the UPS. So, you know, it's 97% charge here. Battery manufacturing date, CPS. This is a lot of these consumer level UPS units do crazy crap like this where they just put the wrong thing in the wrong fields. I mean, this runtime of 45,341, I mean, surely that's not hours, but who knows. So anyway, and then next kind of sanity check we can do here is figure out what our IP address is. Because I already know that. If I didn't know it, how would I SSH into it? Man, that's brilliance right there. Is do UPSC minus L and then IP address. That way it's not going over localhost. And then we can see that it's still there. So now the next step, we've got NUT running on the RPi, and we can, plug it in. Actually, let me do that here. We can take the power lead here. So this is the video going back to my capture device, but this cable in the center USB, center USB is plugged into the USB-B, and this one on the end of it is power. So we'll plug it in right here. And then we had the light come on. So I'm going to go back to HDMI. And then we can see that it's booting up. Okay, and now I'm going to switch back to PuTTY. And, yep. We'll have to restart session. And then now we can unplug this video on here. Because we don't need that anymore. And then that can go away, but we don't need that. So, this is completely self-contained here on this. So now we can put like a piece of tape or something on that and just clip that to the side. And now it's basically giving this UPS Wi-Fi capability for us to monitor it and control it. So next, let's get this added to Home Assistant. Okay, so here we are back at Home Assistant, and I don't have my solar charge controller hooked up. It's on the shelf over here, but let's go to Settings and then Integrations, and we see that it is already auto-discovered network UPS tools just because that Raspberry Pi we set up is on the same Wi-Fi network. So let's go ahead and add this. And then it's already found the IP address and the port. We just need to give it the username, the ultra secure admin one that we set up in that config, and it should bring everything over. So let's go ahead and hit submit here. Now, then we can put whatever area we want on that. I'm not going to mess with it, but here we go. We see that battery charge 100%, input voltage. We're not really using anything on the load, so and then of course all of this will generate history. Let me go ahead and unplug the power to the UPS, and we can see what it does here. Okay, it's unplugged. It's going to beep at us. I don't know how quickly it pulls this data. Yeah, here we go. On battery discharging. I don't know why it says input voltage 120. Because input voltage should be 0. But anyway, so you get the idea here, or we can monitor all of these things. Although I figured it would update a little bit quicker than this. See if we can go back to the original or overview here. Here we go. It finally updated to 0 volts. And we can plug it back in. So I plugged it back in and the input voltage went up. Nothing changed on the battery charge. I don't know how sensitive that's going to be. But so we've got the data from the battery backup into Home Assistant. Now, there is one further step that I'd like to go on this, and that is to be able to shut down the UPS, because these things do consume power even if they're off. But if I can put a smart plug on where the UPS plugs in for power, but if I do that, then if I turn the smart plug off, the UPS is just going to stay on because it's going to think it's a power outage. So we can use Home Assistant here to send a command to the UPS to turn itself off. Then we can turn off the smart plug if we want to, and then be able to turn the smart plug back on to bring everything back online. So let's go into how to do that. So with what we have so far, we can monitor and then issue a remote shutdown command to the UPS to turn everything off. However, since this is now off, there's no way to turn it back on. So if we combine this with a smart plug, then we can tell Home Assistant to tell the RPi to tell the UPS to shut down, and then set it to where if the power comes back to automatically start. Then turn off the smart plug, and then everything is off, not consuming any power. And whenever we want to turn everything back on, we just turn on the smart plug, which will automatically turn this on, automatically turn this on, and then set us up for whenever we want to shut it down. So the smart plugs I like to use in this instance that are local Wi-Fi are these Shelly plugs. And this is pretty easy to set up. So, I mean, they look like just about any other kind of smart plug or whatever. It's got a button on it and an LED. But let's go ahead and plug these in to here to set it up. And then we'll notice this little blue LED is blinking, and what this is going to do is set up its own local access point that we will need to connect to with our computer so we can configure it. Okay, so we want to go down here to our Wi-Fi and then see if we can find one that says Shelly plugs. So we'll go ahead and connect to that. Sometimes this does take a while. I'm not sure why. Okay. Now we can go into our browser here. And this is in the documentation that comes with the plug, but we just need to go to 192.168.33.1, and then we're asked to configure our Wi-Fi settings, and this will allow the plug to connect directly to the Wi-Fi so we don't have to connect to it to configure here. So we want to enable Wi-Fi. It's not an open network. It does need a password. And then we'll use the one closest here. And then hit save. Okay, so letting this sit for a few minutes, we can now see that it has gotten an IP address. We will need this if we can, goodness, copy it here, so that whenever we switch back to our Wi-Fi that we can actually find this thing. So let's go switch back to that. Then we can just paste that in here. And then here we are. And the first step, well, the second step I like to do is go over here to Settings and Firmware. And let's go ahead and get whatever the latest firmware is. Okay, let's hit refresh page. And then sometimes you have to go through this a couple of times. Okay, now we're done with the updates because there's no more to do. So the next thing, let's go back to settings. This access point, we don't need this anymore since it's connected to the Wi-Fi, so let's turn that off. And then Bluetooth we can leave on for now. We'll use that probably in another video, but we do want to go down here to authentication and give it a password. I mean, just something. This way it's just not open on your network. And now that that's all here, we can turn that off and on, which, you know, you can hear it click there. All right, so now that this is done, we can add it to Home Assistant. So let's go back here. And we've already got, you know, the UPS stuff in here. So let's go to settings and, well, we got some updates. We'll do those later. So it auto discovers the Shelly plug, and it's going to give it a name that has the MAC address in it. We'll change that whenever we add it. And yes, we put a password on it, so you need to type that in. And I'm not going to mess with an area on this. So let's change this name to something a little bit better. That's my UPS plug. Isn't that such a better name? And these also have energy monitoring on here too. So you've got everything going there. So now that this is part of Home Assistant, then let's go ahead and plug the UPS into this and then plug this into power here. Take this out of here. And then this is from the UPS, and plug it in like that. Yep, we got some beeps. And then we'll go ahead and turn that on. Okay, so this is the wrong mouse. So let's go back to our computer. And then go back here. And look, we're drawing 5 watts. And this is just for the UPS and the Raspberry Pi. And then we can see all that there. And if we want to test our UPS, you know, we can just do that. And really, this should say, well, let's silence that. By the way, on these, if you hit the power button twice in rapid succession, it silences the stupid alarm. I do not like how this takes so long to update, because clearly we have no input voltage because we've just turned the switch off. Let's see if we can go into the nut integration itself and yeah, I don't know. I don't know why this takes so long. Let's look at our logs here. Okay, here we go. It finally updated. On battery discharging. Okay, so let's go ahead and turn it back on. And then we see now that we have a consumption of 12 watts because now it's trying to charge the battery on here as well. Okay, so now all the hardware is set up. Now we need to create an automation that says, hey, whenever I trigger this, then I want this whole thing to shut down. And we really need to add a button. And I think we can do this with a helper. Yeah, we want to do a button. I'm going to call this Shutdown My UPS. And then we have like a... Yeah, here we go. Let's do this. And we'll create that. Alright, now will that show up on our... There we go. Alright, we can press that, nothing happens. Because we need to create an automation to actually do what we want. So we'll go over here under automations. We've got our ones from whenever we were working on the solar charge controller. So we'll create a new one. When we press a button, button. No triggers found for button. Oh, hang on. We need to do... can we do a device? Is that a device? Select a device. No? Well, don't listen to me. Uh-oh. Delete. All right, maybe it's entity. Select an entity. Shut down my UPS input button, what we just created here. Okay, that's where it is. And then okay, I think this is right. I have it on another system, and I think just having this trigger here is enough to do what we want to do. So first thing we need to do is tell the UPS to turn off the load. So we'll look for my UPS. There we go. Then action is This is the one we want. Turn off the load, possibly after a delay. Some of these have, the APC ones seem to have a delay. The CyberPower ones don't. I don't know what that's all about, but return when power is back. That's critical here. So we'll do that, and then we'll add another action to our plug to turn it off. Okay, let's hit save. And then we'll call this shutdown. Oops. Okay, so this is all set up. Let's go back here. All right, we can watch these two screens here, and then I may flip over to the cam to kind of see what's going on, but let's go ahead and try this. Okay, so everything is turned off. There's no LED on this. This is off. The plug is off. And then now, whenever we turn it back on, all of this should reboot or come back up. Or not. There we go. Man, I'm just too impatient on this stuff. Okay, so we got the little green LED on this thing, and it's blinking, so it's doing stuff. So we know that the UPS itself is on. And then we see it's consuming some power here. This should refresh here in a bit. Maybe we have to refresh. Yeah, okay. Well, waiting on me on that. So there we have it. If we just had turned off the smart plug, the UPS would simply interpret that as a power failure and just keep running until the battery died. But combining it with the Raspberry Pi and the network UPS tools and interfacing to the UPS itself, we can, trigger things here to where it tells the UPS, hey, I'm going to unplug power, but you need to turn off before I do that. And how I have this set up at like my house is, let's say I have a TV and some stereo equipment and whatever, and I can have a button to where I just press that and everything shuts down. It's drawing zero power until I need it again. I press the button, everything powers up and works as it should. So anyway, I think that's all we're going to do here on this video. So as always, thanks for watching. Hope you learned something. Please leave a comment, like, subscribe, all that good stuff. We'll catch you on the next one.